Section 4.4 is on page 238, talks about vectors, and just like complex numbers and polar coordinates, we're going to do the same here, except vectors have two types of representation. One, geometric, we're going to do that today, and in the next class session we're going to go over the algebraic along with the polar graph, section 4.2. So what's a vector? A vector is a quantity that has both a magnitude, that's our R, they call it magnitude in this section, and direction. Instead of saying theta, they refer to it as direction. Notation, they use a different notation for vectors, quite a few of those. If I take the following vector, assuming it starts at this point A, and the arrow right there doesn't indicate this is array. This is not infinite, this is finite. So one way of representing this vector is to say that's vector V. You put an arrow on top of it, and we know that that's a vector. It starts at A and ends at B. Another way of representing that is to give the beginning letter and the terminating letter. That is, the letter that corresponds to the starting point and the letter that corresponds to the terminal point. Or I could simply say V, but if I write it in bold letters, that would be referred to as a vector. In my notation, I will always use this or this on an exam or a quiz. Bold letters, I'm not into it. You'll notice that this vector is not horizontal. It has an angle to the vertical. And that right there is our traditional R. Here they call it magnitude. So now we're going to get into the geometric interpretation of what these are today, and tomorrow we will get into the remaining parts. So I'm looking at the first set of problems, and here it's kind of like a game, and I'll give you an example of what that stands for and how to play with those so that you can apply them easily. So use the vectors in the figure at the right to graph each of the following vectors. So what you want to think of vectors, you want to think of vectors as moving belts. You know, like at a mall, you could take those stairs, those moving stairs, up or down. At an airport, they have those flat in which you could stand. Sometimes people walk on them. You want to think of those as moving, like you want to upload the luggage into a plane. You really need to line up that moving belt with the storage unit on the plane, and you want to drop the baggage right there. And what this vector tells you, it moves up. When you want to unload, you got to reverse the order. So here we're going to start talking about what a resultant is, and this is really how this works. It's not that hard, just different. Let's get used to it. They say use the vectors in the figure at the right to graph each of the following vectors. Now you'll notice the graphs they have, that is, the units they have, are smaller than the units that I have here. Let me see if I could match those. That would be great. Shrink them a bit. No, too small. I can't custom those. Well, that's okay. Let's keep them like that. Not a problem. Assume the units are matching. So this says take vector u, and vector u is right there. If you notice what vector u does, u shifts one unit down, two to the right. So if I take a point and I drop it off, that is going to shift one down, two to the right. I'm going to assume those units are the same. That's vector u. Now, what does vector v does? Well, v, 1, 2, 3, 4, v moves horizontally. Anything you drop at v, 1, 2, 3, 4, 5, it shifts 5 units to the right. anytime you're adding vectors, pretty much this is what you're trying to figure out. If I drop my baggage right there, and another one of those moving belts picked it up, so if I am to go in a straight path from where I dropped it, where did I pick it up? That right there is called the resultant, and it's simply u plus v. Resultant is, if I dropped my baggage at the very first location, after all the vectors apply to it, where do I pick it up? You end up picking it up right there. You end up moving 1 unit down, and 1, 2, 3, 4, 5, 6, 7 units to the right. For now, this is all we're doing, and this is on page 248. In the next discussion, when we get to the actual algebraic manipulation, then you have to find these numbers and so on and so forth. For now, we're just playing with this a bit, kind of like a puzzle. I'd like to look at number 16 next. And I notice number 16 does something slightly different. And again, geometrically, what do you think that means? Well, they started with u again. Let's say I drop the baggage right there. Well, what u does, shifts 1 down, 2 to the right. This is what u will do every time. So right now my baggage is right there. I go to vector v, and I notice they said negative v. If v shifts in that direction 5 units, what do you think negative v will do? Negative v will shift whatever you drop at its base. Instead of shifting it 5 units to the right, it's going to shift it 1, 2, 3, 4, 5 units to the left. And it's pretty much like doing opposite. If you go in, and if you go on one of those moving stairs in a mall, well, if going up is positive, coming down is negative. Now, the resultant for this, well, we should know how that works, hopefully. Where do you drop off the baggage? And where do I pick it up? And that's pretty much, if this is u, and this is minus v, then guess what? This right here is u minus v, which is the resultant. So the idea is not that bad, just a bit of work. And let me see if I want to look at the next problem. And this is a bit lengthy, but it's okay. We have all the room. So what we're doing here, we're taking double the belt. So when I take u, u shifts 1 down and 2 to the right, but here I'm taking 2 of them. So let's say I drop off a baggage right there. What u will do, will shift it 1 down, 2 to the right, right? But then I'm doing that again. 1 down, 2 to the right. So that's 2u. Of course, you don't need 2 vectors. You could draw the whole thing as one line, and let's say this is really how it's going to look. So this is the vector 2u. Then we have minus 3v. Well, I know what v does. V shifts 5 units to the right. Negative v is going to shift 1, 2, 3, 4, 5. That's one of them. 1, 2, 3, 4, 5. That's another. 1, 2, 3, 4, 5. That's a third. So I could do those one at a time. That's one. That's another. And that's a third. Or I could say, you know what? It's the same thing as just running all across. Ooh, my. Now, what does w do? Well, what w does, it takes any vector, shift that 2 to the right, 1, 2, 3, 4, 5 up, 5 and 2. It's going to shift 1, 2 to the right, 1, 2, 3, 4, 5. Ooh, I'm running to the other graph. It's okay. So, if I want to know what all of this mean, well, it's very simple. Where did you drop off the baggage? Oops. Where did you drop off the baggage? I dropped the baggage right there. And if I go in a straight path, where do I pick it up? And this is pretty much the vector 2u minus 3v plus w. Alright? Now we're going to play a game, and let's see how this goes. And here's the game. Use the figure at the right. Determine whether the statement is true or false. Well, this is the figure at the right. Oops, I cut it off. Okay, let's look at some of those. Let's look at 20. Let me see. 5 minutes. Let's do 22. And let's do 26. Those three. And if I get this is like a puzzle. So, I'm going to start with the first and see if this is true or false. That is, if I moved at K, so meaning, if I dropped my unit, where's K? If I dropped it right there, what does K do? K shifts down, now I'm right here. And what does G do? G will shift it back, in this, I shouldn't use that color. Let's use green. G will shift this that many. Now I'm right there. And they're saying that's the same thing as F. What does F do? F will take this, and wouldn't F send it up that way? So this is false. Negative F would have been true. Alright? So I'm going to erase those and restart the process one more time for the next problem. Negative F would have really took this unit and dropped it right there. So I am at the same location. That's true. If I go for the next problem, let's say I'm looking at G. Where's G? So I'm starting right there. G dropped me off right there. H. What does H do? H will shift any unit 1, 2, 3, 4, 5, 6. So this is going to shift 1, 2, 3, 4, 5, 6. Now my item's right there. What does E do? E shifts any unit 1, 2 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So drops it 1, 2 units and shifts it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right there. Right? And they're saying, so now I am right here. They're saying that is equivalent to you, instead of doing all of that, you could have just used D. What does D do? D, all what it does, it takes any unit and shifts it 2 units down. Well, if I started right there and went 2 units down, isn't that the same location? So which means this is true. Instead of doing all of that work, you could have just used the ladder or the moving bell D, and that would have done the job for you. Alright, I'm going to erase this and tackle the last part, and let's see if that's true. This says, start at A. So I'm starting right there. I'm going to go up. Now I am right here. Then apply B. Well, there's B. Now I'm right here. Then apply C. Now my baggage is right there. Then apply H. And lastly, let's apply G. Where's G? It's saying it's the 0 vector, which means you're back to where you started, and that is true. Okay, so this is the geometric interpretation of these vectors. Now, the next batch of, or the remaining part of the section deals with us figuring out how to do this algebraically, which is really what we need. I wanted to do a bit more, but I really can't fit what I want next. I'm going to make a short video for that. So we're going to stop here, And this is the homework, and we will finish this and section 4.2 in our next lecture.